Hello engineering students, it's Mr. O again. I'm going to go through question number one. Question number one, straight away, I have a look at it and it has a support on either end of the beam. The triangle with the base ground tells me that reaction is a fixed or a pin reaction, and the one on the far right hand side is a supported beam. My brain is going a bit crazy at the moment. That's a simply supported beam with a roller support on the outside. Okay, I will do the first thing, which is very quickly and briefly redraw this beam. So I have a triangle, I have a beam, and I have a circle. So this is my fixed support, my left hand side, and this is my roller support. My roller support immediately I know is going to only be supporting it in one way, which is a vertical way. So this is the reaction on my right hand side, this is the reaction on my left hand side, and I'm going to be looking for a force on the right that is vertical, because it really says calculate the reactions. What force are these going to be supporting that beam? And on my left hand side I'm going to have two forces because it's a fixed or pinned. Force left vertical, force left horizontal. I have two forces over here, a 12 kilonewton force and an 18 kilonewton force. So I'll just draw some little dotted lines down so I can figure out how far these are from each other from when I do my moments calculations. So my diagram says, I'll move this over so you can see, I don't know if you can see it better, 3 meters. So 3 meters from there to there, from the left hand fixed support to the first force. It's then 2 meters, my scale is not very good at the moment, and then 1 meter to the end, which means my in total, the length of my beam in total is 6 meters. 3 plus 2 plus 1 is 6. Okay, have a good idea there. My assumptions are going to be, this is in the beam is in equilibrium. What does that mean? That means my clockwise moments and my counterclockwise moments will cancel each other out. What does that mean? The sum of my moments will equal 0. And as I've done many times before, I can solve that by saying clockwise or counterclockwise moments, the sum of the counterclockwise moments equals the sum of my clockwise moments. This will go over to the other side, plus clockwise moments minus counterclockwise moments. Basically, I'm really just proving that. The same thing when it comes to my vertical and my horizontal forces. Okay, plus, minus. My forces downwards will equal my forces upwards, and my forces to the left will equal my forces to the right. Okay? And in reality, if I take this over to the other side, this will be positive and then it will be negative. This will be negative and this will be positive, obviously, when it comes over. Okay, so these are my assumptions done. What I'm going to do now is the next step is to go number 2. I'm going to say, take moments around, so take moments about the left hand support, and by taking moments about the left hand support, what I'm going to do is find the right hand support, it's force upwards, which actually I'm going to be looking for the vertical force. Because if I take a moment about that, all my references are from there and I'm left with an unknown, which is that. So let me do that. sum of the moments around the right hand support must equal 0, and which means if I go back to here, my clockwise moments minus my counterclockwise moments. So straight away, if this is going to be my pivot point, then I'm going to be basing everything on the distance from there and the force causing that beam to act like a seesaw, or pivoting from that particular moment point. What forces are going to cause it to go clockwise, and what forces are going to force it to go anti-clockwise. So straight away, there is going to be two forces, 1 and 2. So therefore I can go force times distance plus force times distance. I know there's two forces pointing that way, causing my beam to go clockwise. I also then have a single force from this here causing this beam to go upwards, which is going to be force times distance. It's only one of them, which is my support for my beam. For my support. Let me move down a little bit, so I'm going to go plus 12 kilonewtons. I have checked to see that the units are all the same, so I don't have to do any other calculations. 12 kilonewtons times, how far is that from the left hand side? 3 meters. Plus, that one is 18 kilonewtons times 5 meters. 3 plus 2 is 5. It is 5 from the left hand side. And all the forces now causing, because that all of that together is positive, all of that is going to be negative, hence the negative. The force is going to be the force of the right hand side vertical upwards. It's an unknown, I don't know what it is, but it is 6 meters away. So effectively, it is the force of the right vertical times 6 meters from my pivot point. There we go. So now I just solve for it. 12 times 3. 12 times 3 is 2436. 36 kilonewtons per meter, because it's kilonewtons times by meter, plus 18 times 5. I am not that quick or that good, so I'm going to go 18 times 5 is 90 kilonewtons per meter, and 6 meters times force of the right vertical. What is 36 plus 90? It should be 126. There we go. 126 kilonewtons per meter minus 6 meters. I will take this, because it's negative, I'll take the other side and make it positive. So it becomes positive 6 meters times force RV equals 126 kilonewtons per meter. I now divide by 6. This will go underneath. If RV equals 126 kilonewtons per meter divided by 6 meters, the meters cancel out. 126 divided by 6 is 21. 21 kilonewtons. It's still positive. If it's positive, the force is upwards. I have now solved what my force on the right hand side is. And also it's a rotor support, so it's only one. Okay, now, very quick way. The next step is to, and I'll tear this off so I'll give you some space so you can see it. Okay, step 3. Now we're going to solve. So we have only one to solve there. We've solved by taking moments about RL. What we've done is we've solved this unknown. Now we're going to solve both of those unknowns. Instead of using the moments, we're now going to go just up and down. The sum of the forces up equals the sum of the forces down, and the sum of forces left equals the sum of the forces to the right. So what we're going to do now is we're going to solve the forces on the left vertical and the forces on the left horizontal. Straight away again, we can see there's only normal forces at 90 degrees. Okay, these are the unknowns now. So horizontally and vertically, there are no axial loads. If there's no axial loads, then the force horizontal equals 0. Done. Now, force of the left vertical, so now the force upwards is pretty simple. How do we solve that? All the sum of the forces downwards must equal the forces of the sum of the forces upwards. That's because the beam is in equilibrium. And over here, the whole beam is in equilibrium. So how am I going to solve this? Pretty simply. What forces are going downwards versus what forces are going upwards? I can do it that way, or I can take this over to the other side, make it 0, and then find it as well. I can actually show you both ways right now. I'll do that pretty quickly. So let me do that check. Okay, so over here, if I just do the sum of all the forces downwards equaling all the sum of the forces upwards, all the forces pointing downwards, there's only 12 and 18. Okay, so therefore it's 12 kilonewtons plus 18 kilonewtons. How many forces are pointing upwards? Well, there's only 2 forces upwards. This is a really simply supported beam. We know what that one is. We know what the force of the right vertical is now. So that's going to be 21 kilonewtons. And we also know that is pointing upwards as well, but we don't know what it is. In this particular manner, both are positive. Remember, we haven't taken this over to become a negative. So this is just going upwards. Doesn't really matter. Forces downwards, 12 and 18. Forces upwards, 21 and unknown. Force on the left, vertical. So what's 12 plus 18? That would be 30. 30 kilonewtons equals 21 plus force LV. I want to take that over to this side. It becomes 30 minus 21 equals force LV. Force left-hand side vertical is 9 kilonewtons positive, which means it is also pointing upwards. So you see how simple that is. I didn't have to worry about this particular idea, which is forces up or negative, forces up or positive, forces down is negative. I just went that side equals that side. Downward forces equals upward forces. This is a way I can do it without confusing myself. What I could have done also is just gone exactly what I said there, but extracting it to the next level, which is the sum of the forces upwards, which is positive. When it goes over there, it becomes sum of the forces downwards. So all my downward forces are negative, and all my positive forces are upwards. Very much like this. All my downward forces are negative, all my positive forces are upwards. We'll get to the exact same answer. So all I do is the sum of all my upward forces. And what is that? That's support. FRV plus FLV. And all my downward forces is 12 and 18. 12 plus 18. added together, the sum of all of them. Which then, now I know what F R of V is. So that is 21 plus FLV minus 30. So 21 plus FLV, because I just times it through by positive, minus 30. What does that say? Negative 30 plus 21 is FLV minus 9. I take that to that side, it becomes positive 9 FLV. Same thing, it's positive, it's upwards. I've just proven both ways by either just saying up versus down, or because it's an equilibrium, I take that over to the other side. One becomes positive, one's become negative. I've just showed you both ways. And then the fourth thing to do is to just take your force diagram. Arrow up, 12 kilonewtons, 18 kilonewtons, 21 kilonewtons, and 9 kilonewtons. Don't forget this, 0 kilonewtons. There's my force diagram. There we go. That is it. Support on the right, support on the left, 0 and 9, proven in two very similar ways, and the two forces, and that is it. Hope that helped, guys. I will scan the saucer and put this onto pack.